Hi, I'm Jack, and I'm a rising high school senior in the Bay Area, like in San Francisco around there.
Great.
And thank you for your time.
Yeah.
Um, I was interested. Okay, so I saw the the tour of your company, like the machines that you use to assemble your products, and I'm kind of interested in like industrial design, like designing like products and like ship and then like assembling them and stuff.
Yeah.
What sort of company did you like get your machine from? Did you like ask like another company to make like the machines,
Hmm.
design the machines for you, or did you guys do it yourself?
That's a
And
good,
did you
yeah. Oh,
have to
sorry.
cut? Sorry, did you have to customize like certain parts of it?
Uh, so the machines that we use to assemble electronics are called pick and place machines. And there's actually a couple machines, even though the pick and place is like the core of the process. There's a stenciling machine, and that's like a silkscreen machine, but it uses a metal stencil and it deposits the paste, and you get the pieces laser cut. There's a feeder that feeds boards in, kind of like a Pez dispenser, like you stack them up and it just kind of shoots one out into the machine. So that it goes from the board loader. The board shoots out, goes into the stenciler, it gets stenciled. It goes down to the pick and place, and that's what actually picks up the components off of reels and places them. And then it goes into a little inspection station, which is, sometimes you look at it, sometimes you don't. And then it goes into the oven where the components are melted onto the circuit board using the paste that was deposited in the stenciling step. So these are off the shelf machines. There's a lot of electronic manufacturing happening in the world. There's a couple companies that are very good at making these machines, and so these machines are not inexpensive. They're $100,000 or more per machine, but they do the job really, really well. And if you take care of them and you clean them and you fix the belts and you tighten them and all that good stuff, they'll work very well and very fast. This is a technology that's been around for many decades, and so as humans, we've gotten much better at making them, and relatively they're inexpensive compared to the amount of work that they do. So they're not customized, although sometimes you can do like add-ons. It's like, oh, do you want like two reel holders, or do you want like this stick feeder? There's little details, but for the most part, the machines are not custom made. The this is different than if you're at like a factory, right? Where it's like you want to, for example, make a machine that makes face masks or something. So for that, you would have an industrial engineer, and the industrial engineer would take various motors and pulleys and gears and subsections, and combine them together to make a custom machine, which is very difficult. Usually there's a couple engineers involved. And I think another tough thing is getting it to be reliable. Reliability is actually, it's not hard to build something, right? Like anybody can make something. The difficult part is, can you engineer it? Can you make something that is a reasonable price, that doesn't break, that works reliably, that does the same thing over and over again for 10 to 20 years? And that's where engineering is separate than making. And that's why people go to school for engineering, is they're like, I want to learn that skill set. So those are the kind of equipments that we have. But depending on what we might need, like if we have injection molding needs, we have another factory that would do injection molding. They have that equipment, and that's part of the deal. It's like you get the machine for the thing that you're doing the most of.